We've all been there. Your package arrives damaged. You take photos, attach the invoice, and submit a refund request. Now it's in the queue, waiting. Now zoom out. Support is drowning. Hundreds of tickets pending. Agents verify orders, check eligibility, and chase policy details. And when anything's unclear, it gets flagged, and customers wait. Meet VARA AI. Refunds in about 90 seconds, end to end. Every decision is grounded, with policy evidence you can trace. And if a case is ambiguous, VARA escalates it with a clean summary for human review.
Here's VARA AI in action. I select a real return request, and with one click, the pipeline starts. First, VARA classifies the email intent as a return. Then it parses the invoice and runs Vision on the photo to confirm the defect. Next, an LLM extracts the key fields into a structured JSON case: order, customer, item, and reason. DB verification then confirms the order is verified against our database. Finally, the adjudicator consults Neo4j, cites the exact policy evidence, and returns a clean verdict, approved, along with a drafted response back to the customer. Next, here's our policy compiler in action. With one click, we take raw policy text and compile it into a knowledge graph, turning rules into nodes and conditions into relationships. As the graph builds, you can visually explore what the policy actually says. For example, here we have two nodes, return denied and scratched. The edge applies when connects them, meaning return denied applies when the condition is scratched.
Now, let's see what's happening under the hood. This first diagram is our multi-agent knowledge graph pipeline. We ingest policy PDFs and convert them into structured, hierarchical text. The ontology designer agent defines the graph schema, what entities and relationships matter. Next, the extraction agent pulls policy triplets, links them to that schema, and generates cipher statements. A critic agent validates those statements and loops back until they're correct. Finally, the graph builder executes the cipher statements into Neo4j, so VARA can make grounded, explainable decisions. Now, let's look at the end-to-end refund workflow. The Gmail event processor triggers on every new support email and extracts the core components: message, metadata, and attachments. Using MCP routing, the doc server parses the invoice and the defect analyzer runs on high-modality images to assess the damage. Next, the extraction agent uses an LLM to pull the key refund details into a structured case. Then, DB verification becomes agentic. It selects the right tools to find and confirm the order, and if no match exists, an LLM writes targeted SQL queries to retrieve likely orders and route the case to manual review. Finally, the adjudicator consults the Neo4j policy graph, cites policy evidence, and returns an auditable verdict, approved, denied, or human review, with a drafted response back to the customer.